Hello guys, in this video I'll talk about LC oscillations. So what do we mean by an LC oscillation? Let's say a charged capacitor when connected across an inductor of inductance L and switch is closed, the energy transfer from electric form to magnetic form and then again back transferred to electric form, and this oscillation of energy takes place continuously, but the total amount of energy remains same at any instant because there is no energy dissipative instrument, which is resistance, present in the circuit. So if there is no resistance, the energy will continue to oscillate forever with total energy to be constant. So that type of oscillation is called LC oscillation. Okay, so let's say at time t, at any time t, after closing the switch, let's say the current flowing is I. Let's say the current flowing is I. So we can say I is basically minus dq by dt because the charge is decreasing on this, and q naught is the initial current. Initial charge on the capacitor. कैपेसिटर पर शुरू पर इतना चार्ज था. Okay, so applying KVL, I can say this plus Q by C minus L di by dt is nothing but 0. So Q is equal to LC di by dt. Again, on differentiating, or just put the value of I as dq by dt, we can easily get minus LC d2q by dt square as this. So we can write d2q by dt square as minus 1 by root LC square of that into q. Why I'm writing the in this manner? Because I have to compare the equation like d2x by dt square is equal to minus omega square x, and this is a very famous equation for SHM. So we can say the charge will perform a simple harmonic oscillation. So q can be written as q naught, which is the maximum or initial charge, sine omega t plus phi, and as at t equal to 0 charge was maximum, so we can say at t equal to 0 q was q naught, implies phi is nothing but pi by 2. So we have q is equal to q naught sine pi by cos or omega t plus pi by 2, which can be written as q naught cos pi by 2, cos omega t. Okay, and we have I as minus dq by dt. So I is nothing but q naught omega sine omega t. This is the equation for current. Okay, talking about energy of capacitor is half q square by c. So it will be half q naught square by c into cos square omega t. And energy of inductor, which is ul half li square, is nothing but half li square is q naught square omega square sine square omega t. Putting the value of omega square as 1 by LC, we can easily get half q naught square by c sine square omega t. So we can easily see ul plus uc is always constant. One is cos square, one is sine square. So it is nothing but half Q naught square by C, which is the initial energy of the circuit. Okay, so let's solve few questions. So let's solve this question. The initial charge on the capacitor is Q naught, capacitance is C, and inductance is L. The circuit is closed at t equal to 0. So after closing the switch, find the I max. So to get I max, we must know that I max, either you can solve it by using energy conservation or you can derive the equation. I am using energy conservation. So half L I max square, which is the maximum energy in the inductor, will be same as the maximum energy in the capacitor, Q naught by C. So I max by this way is nothing but how much? Q naught 1 by root LC. You can also remember it as Q naught omega is the maximum current. Frequency of the oscillation, obviously frequency of the oscillation is omega by 2 pi. Omega is 1 by root LC, so it will be 1 by 2 pi root LC. So the time when UL equal to UC. Okay, so again UL equal to UC, I can say one is sine square, another is cos square curve. Again, one is sine square, another is cos square curve. So when they are equal, I can say the phase omega t is pi by 4. So we can say time is nothing but 1/4, or we can just use the equations. You have to find time when UL equal to UC. So write down their equations. UL is sine square omega t, and this is cos square omega t. Both have same initials, so I have already cancelled them. We get omega t as the minimum time is pi by 4. So t is pi by 4 omega. Omega is known to us. So pi by 4 root LC. Okay. Time when UL equal to 3 times UC. Similarly, sine square omega t is 3 times cos square omega t. Just take the root. We will get sine omega t by cos omega t is root 3. So omega t is nothing but 60 degree or pi by 3. Get the time. Current comma charge at this instant. Current is how much? Q naught omega sine omega t sine pi by 6 is root 3 by 2, and charge is Q naught cos omega t, which is Q naught by 2. Q when I is maximum, Q is cos, and I is sine graph. When sine graph is maximum, Q is 0. Q is 0 when I is max. Similarly, we can say I is equal to 0 when Q is max. Okay. At one instant, the complete energy is electric form, and at some another instant, total energy is in magnetic form. Okay. So this type of oscillation can also be analogously explained by an oscillation of a spring block pendulum. The kinetic energy, which is half mv square, is associated with 1 by 2 q square by half li square. L is called the inertia of the circuit, which is m. V stands for I. And the potential energy, half kx square, is replaced by half q square by c. Okay. So analogous explanations are also given in most of the books. Enjoy this.